Okay, so here is a question on differentiation through Newtonian notation. It might be a little longer than some of the previous videos, so we'll take a look at it now. So the first question is to find the derivative of f of x plus g of x. Okay, so it's the derivative of f of x plus g of x. So this is what we're doing. And because we're just adding, oh, where's it gone to? Let me see if I can get that back for you. Sorry about that. Because we're just adding, we can get the derivative of each part separately, individually. So it's going to be f prime of x plus g prime of x. Now we want to do this when x is equal to 3. Okay, so it's going to be f prime of 3 plus g prime of 3, which is equal to f prime of 3 is 7, plus g prime of 3 is 5, so the answer is 12. So the derivative of f of x plus g of x when x is equal to 3, and we can indicate that here, is going to be 12. So the second part of it is the derivative of 3 times g of x minus 2 times f of x. Okay, so the derivative of that. Well, this time, again, it's subtraction, so just like addition, we can find the derivative of each part separately. So it's going to be 3 times g of x, the derivative of 3 times g of x, minus the derivative of 2 times f of x. Okay. Well, when we multiply by a constant, we can sort of remove the constant, so it becomes 3 times g prime of x minus 2 times f prime of x. Okay, if you're multiplying the function by a constant, you can sort of remove it. You can just remove it right in front. So again, when x is equal to 3, that's going to become 3 times g prime of 3 minus 2 times f prime of 3, which is going to be 3 times g prime of 3 is 5, minus 2 times f prime of 3 is 7, so it's going to be 15 minus 14, which is equal to 1. Okay, the next question that we had to do was the product rule, f of x times g of x. So we're looking at we want the derivative of f of x times g of x. Now, the product rule, if you remember the product rule, it's the first. So f of x by the derivative of the second plus the second, so g of x by the derivative of the first, f prime of x. Now, if we want to evaluate that when x is 3, that becomes f of 3 times g prime of 3 plus g of 3 times f prime of 3. Okay, so let's scroll back up here, and f of 3 was negative 1. G prime of 3 was 5 plus g of 3 is 3, and f prime of 3 was 7. So that becomes negative 5 plus 21, so that's equal to 21 minus 5 is 16. So the derivative of f of x times g of x when x is equal to 3 is equal to 16. Okay, we think I had one more of these. So part 4. And part 4 was g of x over f of x. G of x over f of x. We want the derivative of that. Okay, so that's how we indicate the derivative. Okay, well, that's going to be a quotient. So the quotient rule is the bottom by the derivative of the top. So f of x times g prime of x minus the top by the derivative of the bottom, f prime of x, all over the bottom squared, f of x squared. Now, when x is equal to 3, this becomes f of 3 times g prime of 3 minus g of 3 times f prime of 3 all over f of 3 squared. So that's equal to f of 3 is negative 1 times g prime of 3 was 5 minus g of 3 was 3 times f prime of 3, 7 over f of 3, that was negative 1 squared. So that's going to give us negative 5, negative 21 over negative 1 squared is 1. So it's going to be negative 26. Okay. So without knowing any of the functions and just having a little bit of detail, we can calculate the derivatives at certain points of each of those functions. So we saw a sum, a difference, we saw a multiplication by a constant, we saw the product rule, and finally in step 4 we saw a quotient rule. We haven't looked at the chain rule, that's coming next.